Okay, so welcome to one of our next installments of our Globus office hours. Today, one of our top developers for Globus Connect Server is going to be talking about user mapping and authorization, our authentication authorization model for Globus Connect Server. So Joe, go ahead. Joe Bester, please take it away.
Hello. So today we're going to talk about Globus Connect Server's user mapping and what that means, and how you take Globus identity information, map it to local account information so you can grant access to your storage system. So during this talk, we'll talk about some of the policies that exist on the storage gateway level and what they do and how they work together to allow you to manage access to accounts. So we're going to start out and we'll talk a little bit about sort of an overview of what the identity mapping does. Then we'll dive into some of the policies and what the documents look like, and then sort of go through a few deeper examples that show how to actually implement mappings. So when we start talking about mapped collections, we're probably curious, what are we mapping? So the scenario that we're supporting here is that a user accesses Globus via either a web app, command line app, some portal, or other application. They log in with some identity. This identity might come from a campus IT department, might be a Google account, some other organization that the user is affiliated with. And each of these identity providers will give Globus Auth some information about that user. A user can have multiple identities. They might have a Gmail, a campus account, some lab that they are visiting may give them an account as well. And all those can be linked together. And those identities will be presented to Globus Connect Server so that it can choose what account is appropriate to access the data in the storage resource. So there are two main purposes for the mapping. One is to authorize users. So if there is no valid mapping for an account or an identity, then the user is not going to be granted access. It's also to choose what account they will be using when they access the storage system. And the concept of what account is depends on the storage system. For like a POSIX file system, it's going to be the username of the user on that system. For something in the cloud, it might be an account name, or some thing that gets mapped to an account that's appropriate for that type of storage. So there are four main policies that kind of govern the mapping process and the authorization process to go from the login that the user does at the web page to accessing the data storage. The first is the domains, which is a list of allowed domains that must be asserted by an identity provider that the user logs in with. Like I said before, a user can have multiple different accounts from different sources, but you don't really have to care about that if you only want people from your organization ID department to be able to access your resource. So that's like the first level of filtering of identity. The second one is a timeout, which is when the last time the user authenticated with Globus for that particular identity. You can set that as some number of minutes. It could be, scaled up. I think the default is 11 days. And that's based on each individual identity that they have. So if they log in with Globus with their campus ID, but they haven't used their Google identity in a while, those will have separate timeouts. So you can filter out both who they are and when they last authenticated. The next step is to take that identity information that's within the timeout from domains that you want to consider, and then you convert that into the account. And that's done through the mapping, which might be either an application that you write that accesses some database or some text file or LDAP server, or it can be an expression-based mapping, which we'll talk about in more detail later on. After the mapping is completed, if there are successful mappings, there's another layer of allowed and denied users. So even if a user comes from a domain that you will consider, if they map to an account that you don't want to give access to via Globus, you can deny it at this level. All right, so this is the first ugly JSON blob that we're going to see today. This one is what a identity looks like in the Globus system. This is fed into the mapping module in its entirety, and a whole list of these might be presented at access time based on which domain they're from. There's a few things to note. The username, the email may not look the same and may change during the lifetime of the user's account. People's names might change. The only things that are never going to change are the identity ID and the provider. You can use any of these fields or combinations of these fields in the identity mapping to decide what account the user will be granted access to. And if a user has multiple accounts from different providers that you consider, you'll see all those in the mapping module implementation. So this is very similar to the previous slide, but this shows what an application credential looks like. Using Globus Auth, you can create applications that act similar to other types of identities, but there are a few small differences. Some of the fields are null. You can see the email and organization are null. The username is always going to be from the clients.auth.globus.org domain. You can map these in the same way as other identities. You just need to add that domain to your allowed domain list and then map the IDs or the usernames based on what accounts you want them to have access to. And this slide is the last of the JSON for a little while. And this one shows what an identity provider looks like from Auth. And the main reason I show this is to note that while a university may be a monolithic organization, it may have multiple domains that it asserts, and each domain is treated independently at the mapping level. So if you wanted to map both of these example domains, you would have to explicitly list them as allowed domains. And you also need to be aware of how usernames and IDs are allocated within those different domains. If there's no global synchronization, you need to be a little more careful about how you plan out your mapping expressions or mapping program. Okay, so given these identity documents that you'll see as the mapping input, the mapping module will take those and convert them to 0 or more account name strings. The semantics of the account names kind of vary by connector. It might be username, it might be an account name, it may be some arbitrary string. But for each of the connectors on the premium connector websites on Globus, you'll see what the default naming mapping is, and you can decide whether that's appropriate for your system or if you need to do something custom. And another thing is every identity could potentially match multiple mappers that are configured. So the results might be more than one local account per user. So it's a little bit, if that happens, there's an option in the Globus transfer API to decide which of the local accounts to use. So they can choose one or the other mapping. So within expression identity mappings, you can select any of the fields from the identity document, and you can combine them and substitute them into this source expression. the next step is to have a match expression that's going to compare against the source to generate what the output will be. The match expressions can either be regular expressions that match and group parts of the selected source document, or they can be a literal expression that just grabs a particular, compares it literally against another field. The output can refer to the groups in the match expressions, or it can be a static string. So if you want to map all users to the same account, you can do that. If you want to pluck out the username from, or the account name from a username, you can do that as well. And you can mix and match them and have multiple mappings, multiple mapping expressions associated with a single storage gateway. So this is an example that shows two mapping expressions that are for different domains. So in order to have this be effective, the allowed domains will have to include both the Wasamatta University as well as the University of Chicago. The first one is a literal match. So this user account with numbers and that particular domain is always mapped to this user bus. Anything else from that domain is ignored because it's a literal match. The second one is a wildcard match. So every user from the University of Chicago will be mapped to their corresponding account name extracted from the username field of the identity document. You can see in both cases, the source just selects the username field from the identity document. And the second one uses a grouping of all the information before the @ sign and a back reference to that in the output. So that selects just the username portion before the @ and makes that what it is mapped to. This covers many use cases, but there are situations where the usernames don't directly match to the account names, and so there are other ways to do it. When using an external identity mapping program, this program is invoked when a user does something that requires the mapping. The program processes the identity set as a JSON document and returns a JSON document with the mapping results. This allows you to interface with databases, look up entries in a file, query LDAP, or even provision accounts on Access. Some considerations, if you have a multiple DTN endpoint, the program must exist on all of them. It must be in the same path. There are some restrictions that the executable must be runnable by the GCS web user. There are certain SE Linux policies that need to be, that the executable needs to be tagged with in order to run properly. The input to the external identity mapping program includes the storage gateway ID and the connector ID. So if you had both a Dropbox connector and a POSIX connector, you would obviously have very different mappings for those. And so you can differentiate them based on the connector ID. But also, if you had different storage gateways that operated for different research groups, you might have different mappings for those. So it gives you a little bit of flexibility to decide if you want to have a secondary layer of decision-making on the mapping. The input is a pretty simple list of identity documents, and the output is just a list of mappings from the identity ID field to a username for that account. There's a Python module in PyPy that you can use to help develop the mappings. It includes some scripts that you can run to test the mappings, where you can sort of pre-fill out some identity documents, pipe them into the mapping module, and see that it's doing what you expect it to do. So that'll help you validate that your mappings are working correctly. So the input and output documents are very simple. The input contains a list of the identity documents, which are the literal JSON documents that we looked at back in slide 4. Contains the username, ID, provider, email address, name, etc. The output is just a list of those IDs mapped to accounts, and each ID can map to multiple accounts or 0 accounts, and it's all dependent on your mapping algorithm. Finally, after the account has been mapped to, or the Globus identity has been mapped to an account, you can decide whether or not that account is actually allowed to access the data resources governed by the storage gateway. It's a little bit confusing. There is both a user allowed and a user denied list. If only one is set, then the behavior is different than both. If only user allowed is set, then a user must be in that list in order to access the resource. And that is the user account name after mapping. If the user deny is set, but allow is not, then only the listed users are denied, and anyone else that is mapped, if they have a valid account, is allowed access. And if they're both set, then a user must be in the allowed list and not in the denied list. After that, there's another layer, which is a connector-specific user validation check, which does some rudimentary checks to see that the mapping resulted in something that is functional. For example, on the POSIX system, it'll look up the user in the password database. If that username doesn't exist, then the mapping is considered non-usable and GCS won't try to allow access. For some of the other connectors, there are APIs that we can use to see if that account exists or not, and we'll try to determine to the best that we can at that level whether or not the account is valid. And then here's a couple links. The first one is the identity mapping guide that covers sort of detailed reference information about all of the inputs and outputs and identity types, all the policies that are related to identity mapping, as well as a bunch of recipes related to specific scenarios that we think are pretty common. And then the second one is a link to the PyPy project for identity mapping. It contains some JSON schema things so that you can parse the input and generate the output, as well as a testing program that you can use to validate that your mapping is doing what you want. And sort of as a footnote to all this, if you're interested in the multi-user Globus compute, pretty much everything that you heard about in this presentation is the same, so that the identity mapping operates quite similarly and shares the same code. So once you've developed your expressions or your identity mapping, if you want to use the same technology with Globus Compute, you can. And with that, I am done with the presentation.
Excellent. Thank you so much, Joe. I am going to stop recording.